Hey guys, this is Miss Went, and these kind of notes here go with Chapter 1, Section 1. That's what this 1.1 means. So Chapter 1, Section 1 of the physics book. So that's going to be the same as pages 3 through 10 of your book. Okay, now you need to realize that my pages are not exactly like yours. I'm reading from an older textbook. I couldn't get the copy of the one that you guys have digitally. So just realize that some of the pictures and page numbers will be a little different. Things will be in a little bit different order. And I shortened mine a little bit. So this is just kind of an overview or an intro. You still need to read in the book. And I know that's not necessarily your favorite thing to do. But, you know, if it's beautiful outside, go read outside, read in your bedroom, put some headphones on, whatever you like to do. There are lots of pictures and diagrams, so it might look like a lot of pages, but really it's not that many paragraphs, okay? So let's go over what you're going to be seeing on these pages of your book, okay? And you're going to notice that a lot of this stuff is kind of the same as the first chapter of physical science, or kind of any other science class where we just have to review kind of what is science and the scientific method, okay? Now, physics specifically deals with the physical universe, okay? So this little story here talks about spaceship. You can see it's a little dated, 2004. So people are asking, what is physics? And people say, oh, physics is all about complicated math and things you need to memorize. That's not what physics is, okay? Physics is how the stuff around you works. And you have to memorize stuff to know how it works. You know, why do things fall down? What happens if things crash into each other? Why do some things stop and some things speed up and some things change direction? Okay, so how things move, how things have energy, you know, what's the deal with gravity? All that stuff is things that we're going to learn about with physics, okay? So there is some math, but it's all Algebra 1 math. And there is a lot of things that you kind of got intro to in Physical Science A that we're just going to learn more about. Okay, so actually Physical Science A, we kind of spread out for 2 quarters of physics and look more deeply into things, do a little more math, a little more connections into that stuff. All right, so that's kind of the first page here. What is physics? Trying to figure out how the universe is organized, so things like energy. Matter is all the atoms, and everything with atoms and protons and neutrons does fall into physics also, but in high school we do that more in chemistry class, okay? Natural laws, why things work the way they do. So why does gravity make things fall down and things like that? And then applying those laws, so trying to figure out if I do this, this, and that, what will happen next? Okay, that kind of thing. Off to the side here, you'll notice in your textbook there's some vocabulary boxes, and I have made up the words that are important into flashcards already for you. So that link is in Schoology. And the objectives here are kind of what we're trying to do today. So what makes up the universe? How do we use a scientific method? And the effects of energy on a system. And actually this energy one is not in your textbook in the same part of the chapter, so you'll see that later. Okay. Next page here talks about something that's probably new to most of you, and that is what a system is. Okay. And in this paragraph it says the universe is huge and complex. The only way to make sense of it is to think about only a small part at a time. If you want to understand a car rolling down a ramp, you don't need to confuse yourself with the sun or the Milky Way galaxy or even the room next door. Okay, so we are going to try to eliminate some of the outside stuff that don't have much to do with what we're looking at. Okay, so when we want to understand something, we focus all of our attention on a small group called the system. So a system is a group of objects, effects, and variables that are related. You choose the system to include the things you wish to investigate, and exclude things that you think are not relevant. Okay, so if we are going to race cars down ramps, and in your bag of physics tools, you actually got some different size of like golf balls and things that you'll be racing down ramps later this week, we would be worried about the ramp, the angle, so how high the ramp was up, where the car started on the ramp, if it started at the top or the middle, how much mass the car has, how much time it took the car to fall down. Those are all important things for us to pay attention to. In this box up here in the corner, we see in yellow, the system includes all this important stuff, but there's also things we don't have to worry about so much. We're not going to worry about the color of the light of the car, or how much sunlight's coming in, or the windows, or the floors, or the tables, because none of that's touching the car. Okay? And for the first experiments we do, we're not going to worry about friction rubbing on things, because we don't have a good way to measure that at home anyway. So we're just going to know that there's some things we can't control and worry about, and we're just going to be very focused on what's happening inside our system, inside this box. Okay? So that's what a system is all about. And it makes our lives a lot easier, allowing us to eliminate some things that are not really important. Okay. Now, with this setup here, and you're going to be doing this, but instead of cars, you have different, like I said, you have like a golf ball and things like that. You're going to be checking out some different variables. So things that are going to affect the system. Okay. So if you have two different sized balls in your bag, like a bouncy ball and a golf ball, those sizes might affect how much time it takes to go down. The masses of them would be different. We're going to calculate the speed that it goes down. That might affect the speed. Okay. So those are some things that would be variables. The sizes of the masses. Maybe if you have a toy car in your house, like a Matchbox car, you could race the car and the bouncy ball and see what goes faster, where the shapes are different. Okay, those would all be variables, things that you can change. Okay, so you're going to see you have kind of done most of these in physical science. The word system is probably new to you, and that's totally cool. We use systems in physical science. We never worried about the moon and the sun when we were doing labs. We just never talked about it specifically. Okay. Now, when we're doing investigating in the system, we know those as experiments where we try some different things out. And we do this thing called the scientific method. And you've seen this before in other science classes. So hopefully this is a review here of the different parts. The thing that you are changing is called the independent variable. So for this image here, if we change the ramp angles that we drop the balls down, that is going to be our independent variable because we changed that angle. We chose to do that. That is the thing that's causing the balls to change. Okay? Now, the dependent variable is showing the effect of the changes. So this dependent variable depends on the angle. And this, in this case, this would be the speed. Excuse me, guys. Okay, so the angle of the ramp that we set up before the experiment is our independent variable. And then when our experiment is all done, we measure the dependent variable, the speed or the time it took for those to roll down. Okay, before you do the experiment, you might make a hypothesis. So you might say, I think blah, blah, blah will happen. Okay, and we always do this before the experiment. And don't worry if you're unsure, you know, just make your best guess. And if you're wrong, nobody cares. Okay, scientists are wrong millions of times a day across planet Earth. Every time they're trying a new medicine for something, every time an engineer tries a different wire setup for a car or a radio or a computer, those are all hypotheses. And they're wrong a lot. It's not a big deal. Okay, it's just a statement to kind of give you a starting point, and then you go forward from there. If you're right, you're right. If you're wrong, you're wrong, and then you try something new. No big deal. Okay, couple more variables here. Anything that you keep the same, we call a control variable. Now in physical science, we call these the constants. So control variable and constants are the same thing, and I put that in your flashcards to help you out. The thing that you're changing is called the experimental variable. Okay, so in this ramp image, the experimental variable would be the angle of the ramp. That's exactly the same as the independent variable. Okay, independent variable, experimental variable, the same thing. Means the same thing. Okay, a controlled variable, something we keep the same. Notice that the size of all three of these balls going down the ramp are all the same. So that's a controlled variable, something you keep the same. All right, one last little bit here. We use a lot of models in science. So a model is, it can be something like a model of a dinosaur or a model of the sun, where it's something that we can't see because it's really big or it's extinct. Okay, in physics class, we don't really have things like that, but we tend to have models of systems, and we use a lot of computer models to run things. You've maybe used the PhETs or PhETs before. Those are computer models that we can kind of predict what we think would happen before we go try it in real life. NASA uses thousands and thousands of models of rocket ships launching before they build and launch a real rocket ship. Okay, because they want to try to save money and do all their screw ups on a computer model before they build it for real. Okay, so models can be computer models, can be like a math equation on paper that predicts a speed of something or a height of something. Those could all be models too. So we're kind of expanding your idea of what a model is from maybe what it was before. Okay, so that gives you a little bit of info with chapter 1. Again, it's a lot of stuff you already kind of saw in physical science in this first section. And the next section deals with measuring, metric system, more things that you've kind of seen before as well. So I know the first chapter is not necessarily really exciting, but stick with it. We got some cool stuff coming up, I promise. So your job right now is to grab your textbook and to read what we kind of just went over, look at the pictures, realize I skipped a few things, so make sure you do go back and read it. And then look at those flashcards. I have the link for in Schoology of all the vocab words, and just get really familiar with the vocab words. So that's your first job for this chapter. Have a great day, guys.